Right. Okay. So let's kick off. So good morning, everybody. Welcome back to the second day of our containers course covering Docker and Singularity. I hope that you all found yesterday and the Docker material useful, and that you enjoyed the first part of the course. We're going to move on today to look at, as I mentioned, Singularity, which is another container platform. So I'm going to start off with a little bit of general background. I'm going to talk about what Singularity is, why you might want to use this rather than Docker, and also to help you understand a bit about Singularity itself and how it differs from other platforms. So this material is in two general parts. So the first part that we're going to look at this morning is just this sort of basic getting started material, some background, and then working with Singularity containers. And as you'll see when we start to do that, it has many parallels in terms of the general concepts with Docker, but there are also some differences. So some of it will look hopefully a little familiar to what we covered yesterday, but equally there will be some material that possibly is looking a little bit different, and hopefully as we go along you'll be able to develop a bit of an understanding about how the two systems differ and when you might want to pick one or the other. Then this afternoon we'll start to look at some slightly more advanced material. So we will look at how to build Singularity images, and this is a great opportunity to leverage your Docker skills that you learned yesterday, because we'll be using Docker as the basis for building Singularity images, and I'll explain that in more detail when we get to that later on today. Just a sort of a general kind of caveat here, just to highlight that this is a new set of lesson material. So this is the second time that this material has been taught, and it's kind of under ongoing development. So we do welcome any feedback you have in terms of things that you think could be improved or anything that you think could be altered. But also just bear in mind as we go through that this is material that's being developed, and yeah, we're certainly happy to keep improving it and to keep advancing it. And I think as was mentioned yesterday, this is material that's now been moved into the Carpentries Incubator. So this Singularity lesson that I'm going through today is all in Carpentries Incubator, and there's opportunities to contribute material directly there if you're interested to do that and you think there are things that you would like to alter or extend or whatever in the material. So with that, we'll start off with part one of this material and just give you a little bit of a background as to what Singularity is. So Singularity, as I said, it's another container platform, and it is in some ways similar to Docker from a user perspective. So as you'll see when we start working with the commands, some of them are almost identical to the equivalent Docker commands, but underneath it's quite a different system in terms of its architecture. And this is quite important because when we look at running containers, when we want to look at running containers on high performance computing infrastructure, so large scale clusters and things like that, Docker has a number of issues. And these are as a result of the way that Docker is built, and they're not issues that in the sense of a bad thing. They're more kind of design decisions that have been made in the way that Docker operates. But those decisions, while making Docker a hugely flexible and powerful platform for the areas that it's designed to be used, mean that it presents some issues for use on HPC infrastructure. And Singularity, the different architecture of Singularity, means that it is better suited to those kind of platforms. So it's increasingly common now to find large-scale high-performance computing platforms that have Singularity available. And as we'll see very shortly, when we start working with it, we'll be working on one of those platforms, and we'll be using Singularity on an HPC platform to demonstrate this first part of the course. So Singularity is at the moment really best supported under Linux. Windows is not an option for running Singularity at the moment directly. There is not a Windows version. There is a beta Mac version, Singularity Desktop for Mac, I believe it is. It's developing all the time. It's improving, but for now, we certainly recommend Linux as the platform, and that's why we're going to be why we are giving you access to a remote HPC platform on which you can run Singularity for the course, so that everybody has access to an environment where they can follow along with this material. So as we move into this kind of getting started section, we're already now going to be working on the platform ARCHER2 that you've all been given access to. So at this point, you should be in a position where you can sign into ARCHER2 and you can get a terminal. And here is my terminal on ARCHER2. So hopefully many of you or all of you are now at this point. And if you're not, if you could highlight this in the chat or put up your hand, and one of the helpers will come and assist you to get to that point. But assuming that you are now at the point where you are ready to start interacting with ARCHER2, we can see that here I have a terminal, and if I type at my terminal Singularity -- version, we see straight away that Singularity version 3.5.3 is installed here on this platform. You'll notice that in the material, which has just been very recently updated, the latest release of Singularity is 3.7.0. It is developing quite quickly, and there are new versions released quite often. But 3.5.3 is absolutely fine, and that's the version that we'll be working with on the ARCHER2 platform here. Equally, if you are running on your own laptop or desktop, if you have a Linux machine that you've chosen to install Singularity on, then as highlighted in the material, the latest version is 3.7 at the moment. And much of the documentation that we link to in the material will link to the documentation for version 3.7 of Singularity. But you can, of course, go back to the older versions of the documentation. They're very similar at the moment, but if there are differences, it's certainly worth using the version that's specific to whatever you're working with. So, as I say, on this platform, we have Singularity 3.5.3, but the documentation in the material here does link mostly to 3.7. I think it's all now linking to 3.7. So, assuming that you can run Singularity -- version, that means you are ready to go with Singularity. You have a terminal where it's available. A couple of things to note. So there is in the material here this little note about installing Singularity on your own laptop or desktop. We're not going into detail with that in terms of the talk part of the course, but the material is available. There is some information available to point you in the right direction if you'd like to install on your own system. It's, I think, something that we would class as a fairly advanced task. If you're fairly comfortable with doing Linux systems work, then you may find it's not too difficult to do. But if that's something that you're kind of new to and you're not so comfortable with, you may find it a bit more of a challenge. So from that basis, we're not going to go into detail of that. But if you do want to try and run it locally, it's certainly an option. So assuming that you have Singularity available, you can now see that we're able to
Sorry, I just wanted to ask, could you, in literally 10 seconds, outline where you find the difficult points for installation on Linux?
So, I mean, it is very, very clearly documented. So it's not so much that if you're sort of familiar with installing stuff on a Linux platform, you should be able to follow the instructions and it should work. The main thing is that Singularity is now all written in the Go language, so you need to install Go, and that should be fairly straightforward. But I think the reason that we've sort of highlighted it as being more challenging is if you're not familiar with installing stuff and building code from source, because you have to build Singularity from source code in most cases, that's something that you may find more challenging. So the instructions are good and they're fairly clear, but I think it's more a case of how familiar you are with the platform. And given that different people have different levels of expertise with these things, we're not saying that it's something that we'd expect everybody to do. That's really what we're highlighting the challenge there for. So I hope that answers the question. So the other thing to highlight here is that here we're working on, as I say, on an HPC platform. Here we've been able to type Singularity -version, -version, it's worked straight away. So Singularity is in the path by default and it's accessible. On many HPC platforms, software like Singularity is bundled as modules. And so if you go into the platform and you type Singularity, you'll get an error that says command not found or something like that. And in some cases, it's necessary to have to type module load Singularity to actually be able to get Singularity available in the path. So if you are running on your own platform, I think I recall somebody asked if they could work on a different platform. If that's the case, you may find that you need to run module load Singularity to get Singularity to be available, assuming that you know that it's installed on that platform. If you find that it's not available in the path, that's something that you may have to do. Okay, right. So a little note on images and containers. So this is something that I think was highlighted by Andy yesterday in the Docker material, but I will just kind of highlight this again, really, to make the point. So just really to note about the terminology for using the terms images and containers. So images are the files or bundles of files that generally include an operating system and all of the software that you want to run, and potentially some data if you've chosen to bundle that into your image as well. And they're sometimes referred to as disk images or container images. And the image is effectively like a template, you could think of it, of that you can create containers from. So the image is the file that contains all of this content that's kind of wrapped up, and you will use that as the basis for creating a container. The container itself is the virtual environment that is based on an image. So as we'll see here with Singularity, images are files, individual files, in the format that we'll be working with, and we can then create any number of containers from a single image file. So the image file is our kind of template, and then we can start these container environments from that image based on that image. And so that's the kind of terminology in which we'll be using the terms images and containers. And I will endeavour to not get confused between them as I'm going along, but hopefully that is clear. Okay, so let's move on to getting an image and running it. So this is kind of the most basic thing that you might want to do with Singularity. So this is, we saw yesterday with Docker pulling images. This is a very similar kind of example that we're going to start off with here. So something to note that's different between Docker and Singularity. When we looked at Docker yesterday, you might recall that when we did things like pulling images, so we said Docker pull and we gave it the name of an image to pull, we saw several files coming down in most cases. So you would see a number of different files appearing and each one of them downloading in turn. These are layers that make up a complete Docker image. So a Docker image is basically formed of a number of layers that contain between them all of the files that represent the image. And there's a number of reasons why they use this approach. One of them is for reuse. It's great to be able to reuse things because you can reuse layers, and when you make changes, you don't have to resave the entire image. You can just save a new layer on top. There are a number of benefits to using that approach. In Singularity, things are a little bit different. Singularity uses an image format called Singularity Image Format. The files generally have a .sif extension to them. You can see the link here to the information about Singularity Image Format. So if you're interested to find out more, if you follow that, that will take you to some further details. So we used yesterday Docker Hub. Singularity has an equivalent called Singularity Hub. And what we can do with Singularity, we can pull containers from the Singularity Hub. It's also possible to pull containers from Docker Hub. We'll look at that in a little more detail later on. But to start with, we're going to start with this kind of simplest approach, which is going to be pulling an image from Singularity Hub. So following this section of material here, I'm going to start by, I'll just create a simple test directory. I might even have one already called test. Let's have a look. It might tell me it already exists. It does. Let's create a directory called test2. So we go into that directory, so you can follow along here. Now, one thing that you may have an issue with here is that on Singularity Hub, there are a number of limits to down. So Singularity Hub at the moment, I think, is not quite of the scale of Docker Hub. It has some limits on how many times you can pull a particular image. Singularity Hub have very kindly given us an extension to the limit so that we should be able to pull this particular Hello World container more times. But at the same time, the other thing that we have noticed previously is that if we're all requesting to pull the image from the same machine, which we will be in this case because most of us are going to be on ARCHER2 running this, there are limits on Singularity Hub to how many times you can pull from the same IP address. So what you might find is that some of you, if you try this, get an error after a few of us have tried it. I don't know if that's still the case, but we will find out. So what I'm going to do is I'm going to try and pull this Hello World image. So we say Singularity pull, the name of the file that we want to save the image to, and where we're pulling the image from. So shub // this is the prefix that tells us we're pulling it from Singularity Hub. This is the user on Singularity Hub that's created the image or stored the image, and we're pulling the image called Hello World. So if I run that, so I'm guessing that means that several of you have already successfully pulled the image, because it seems that it's giving me a forbidden response. So what that likely means is that a number of you have already pulled the image successfully, and now the Singularity Hub is blocking any more pulls from this particular IP address. Can people put your hand up, or probably easier to put your hand up if you've managed to successfully pull the image? That's great. So we've got several people there. Excellent. Okay. So for those of you that didn't manage to successfully pull it, what I've done is prepared a copy earlier, and what you can do is you can actually copy that from the platform here. So if you run cp for copy, and we're going to copy from home, we're going to copy from the account space for our course, and the shared directory. So this is a copy of the image that I pulled earlier in case we encountered this issue. So if you copy from home the course, the code for the project, the shared directory, and the hello world.sif, and you copy it to the current directory, what we now find is that you've got that image locally. So this is exactly the situation you would be in if the command has worked for you. The Singularity pull command has worked, you will have this hello world.sif image in your current directory. If it hasn't worked for you, if you've got the forbidden response, the same as I received, you can just copy the image that was pre-downloaded for you from this location as shown here into your current directory. So for those of you that it did work for, you will have seen some output that looks very similar to that. So what's happened here? We pulled this image. In this case, the image is, as we've seen, it's a single file, a .sif file, and this is a little bit different to how things work in Docker, because if you recall, when we pulled an image in Docker, we didn't end up with a file sitting in our local directory. The image went straight into the kind of local image repository in Docker. So this is already something we can see that's a little bit different to how things work here. And we have this file sitting here. This is our image, and we can now do whatever work we want to do with it, run it, extend it, whatever. And we're going to look in a little more detail at that now. So we've pulled the image. We can now run it using the Singularity run command. So if you run Singularity run and then the name of the image file, you should see the output. Now, you'll also notice that you're likely to get this warning. So this is just something that seems to be to do with how Singularity is configured on this platform. It's not a problem. It's just warning you that the way that Singularity works with mounting home directories, which I will go into in more detail, but it's not probably relevant to go into that at this moment. It's giving you a warning in relation to that. But so don't worry about the warning that's there now. But you should see the output as shown here, and if you can see that, you've been able to successfully run your first Singularity container. Okay, do we have any questions on that, or anybody having any issues with that?
No, it's just somebody asking for clarification that we were running on the front end nodes at the moment. And, yeah.
Yes, absolutely. Yes, sorry, I should have highlighted that. So this is, as we've said, is a large scale HPC platform, but in fact at the moment we're just doing sort of test runs on the login, the local login node. So there's no kind of parallel computation at this stage. We're not using any of the compute nodes. This is just running on the login node locally. So this is not something you would do if you were running large parallel jobs. But for the purpose of testing and for demonstration for this part of the course, this is the way that we're working. But we will look in more detail at how to run things on the compute nodes and do parallel runs and so on later on today. Okay, so you ran this image and something happened. We got this output. So the question is, what did the container do? How did it know what to do when you said Singularity run? So what we can do here, when we run a container, a Singularity, when we run a container from a Singularity image, the container runs a default script that's embedded in the image. And we can see what that script is. So if we run this command, Singularity inspect -r, we point it to the image file that we've got here. And we can see that within the image, we have this little script embedded. So there is this file /raw.sh, and it's being run via a bash shell process. So that's basically what is happening when the image runs. So this is, I guess, very similar to what we saw yesterday in Docker in terms of the CMD option that you can put in your Docker file. So if you put the CMD option in your Docker file, that tells the Docker container when you run it what to run. This is basically the same as that, or it's effectively the same. So that little script will run when you say Singularity run. Okay, so hopefully you've all been able to get to that point and you can see that. And really now we're at the point where I think we can say we completed the sort of very basic introduction to Singularity. You've been able to hopefully to pull an image, but if not, at least to be able to take a copy of the image that was provided and to run the image, and you can see now it was actually running. So this is, as I say, it's a very, very sort of simplistic introduction, but it's really just to get us started and to make sure that we could all get onto the Singularity platform and to get going. So I will now move on to the next part. So we've actually got a break marked here. I think we'll probably proceed straight on, but I wonder maybe if we just take a very brief 5-minute break, just a sort of comfort break if you want to grab a drink or something, and then we will move on to the next part. Okay, so hopefully you can all see my screen and terminal again successfully. And I can also switch here to check out the chat if I need to, without the video effects. Okay. So hopefully that short break has given you the opportunity to catch up if you were having any issues connecting to the remote platform. Do you have a question to somebody? Sorry. Ah, okay. No, I thought somebody had a question. No, okay, so hopefully that's given you an opportunity, as I say, to catch up with everything and that you were able to get started, because we're now going to move on to some more use of Singularity, some more advanced use of Singularity with showing you how images are stored and some more details about working with images. So we're now on to this next episode, working with Singularity Containers. So Singularity, we saw here that Singularity has downloaded the image, the Hello World image, and we got the file, the hello world.sif file that was stored, or we copied it from the location where it was provided. Now, what would normally happen is that if we remove that file, so if I remove the file from my local directory, so the file is now gone, so there's nothing in there. If we try to pull the file again, you might expect that it will just download it again. Now, I think I'm going to get a forbidden message here again. Yes, it's not allowing us to pull. But what you will find, for those of you who are able to do it, you'll probably all get that message now, is that you'll get a message if you're pulling from a different platform. Certainly, you will find that you get a message that says using the image from the cache. Now, what you might ask is, where is that cache? Because actually we've pulled the thing and the file just appeared in our local directory.
Jeremy.
Sorry.
Yes,
Yeah, go ahead.
We've got a question from, it's a bit more clarification on how Singularity is different from Docker.
Right. Okay. So, so I just give a little bit of background about. I gave a little bit of background at the start about Singularity and Docker and the differences between the two. And really, I suppose the main difference is how the two different tools are architected, so how they're built. So as I highlighted, if you use Docker, you generally need to have administrator privileges. We saw yesterday how if you're working with Docker, you had to, in many cases, have to type root to you have to run as root. You have to type sudo to run the commands as root. And of course, if you're running on a large shared HPC platform, then you find you can't offer people root access because it's a shared platform. There's a lot of security implications. It's just not an option. So running with something like Docker, where there are opportunities to give people, where basically you either have to give people root access, or it provides ways for people to circumvent the kind of the security that's in place to ensure that people can't have administrator access, causes problems. And Singularity runs entirely in user space. From the user perspective, it's running just as a user application, and that makes it much more appropriate for running on kind of shared platforms or large scale infrastructure where you might have many users trying to interact with the system. Was that the sort of thing that you were asking for some clarity on? Right. Okay. But certainly happy to provide more information that we can discuss in the break, or if you've got any further questions, please do add them into the chat, and I can try and address those. But hopefully that gives you some kind of a bit of background. So if we just come back to where we were here, so we had this this process of pulling the image, and if you were pulling somewhere where you didn't get the too many requests error, then you will find that it actually told you, if you've previously pulled it, it will say that it's using the image from the cache. And so the question is, where is the cache and what is the cache? When we previously pulled the image, we just got this file, this hello world.cif file. It appeared in our local directory. But in fact, when the image is downloaded, it's also being stored separately in a cache. So if I list my cache, what we can see is that I've actually got two container files, according to this, in my cache. If you've only downloaded the hello world one, you will see that some output a bit like this, which shows that you've got one image in your cache. And so this tells us how many images are in the cache. It tells us how much space the cache is taking up. If we want to see a little bit more information, we can do Singularity cache list -v. So what you can see here is that I've got the hello world image that was downloaded just before, and there's a bunch of other stuff here. So if you've just got the hello world image, you'll see some nice simple output like the output shown here in the material. But here I've got a lot more information. So what's happening here is that we have this image, which is hello world, which is what was the original one we looked at. It's of type S hub, which means it comes from the Singularity Hub. But what I've also done is I've pulled an image previously, a Python image, Python 3.8.6. This is based on Buster, which is a Debian Linux distribution. And I've actually pulled this from Docker, and we'll go into it in a little more detail later. But basically, this is this OCI type. This is a Docker image, and all of these blob sections are actually the layers of the Docker image, which it's pulled down. So that just gives you a bit of an example of how there are different types of image and that you can pull with Singularity, and that's what the different output is that's shown there. So, of course, over time, if you're pulling lots of different images, then this cache can get quite big. So at the moment, it's only using 103 megabytes. It's not really a major amount, but of course, over time, especially if you're on a shared platform where you might have some kind of disk quota, it depends if you're on a kind of a login node with a local file system. Maybe your disk quota is reasonably limited, especially if you've got some alternative space for storing data. So you might want to be a little bit careful about how much data you're storing in your cache. And if you're pulling lots of images for doing lots of different things, that can build up pretty quickly. So we need to be able to manage our cache. As we've already seen also, if you remove a file locally, so if I was to remove my hello world.cif file, which I did, I can do an ls, it's not there anymore. I haven't freed up all the space because it's still stored in the cache. So while I've freed up my 62 megabytes, in this case, a very small image, from the file that I've deleted here, it is still using up my space in the cache. So it's very useful to know how to manage your cache and be able to control what's in there. So this little note here talks about cleaning the Singularity image cache. So there is a command, Singularity cache clean, which you can run. If you were able to download the image rather than copying it, then if you clean the cache, that will remove it. And you will find that if you then run your Singularity cache list -v, the image will have gone. So there's a little exercise for you to think about here. So if we use Singularity cache clean on its own, that will clean everything from the cache. So it will remove all of it. So if I run that here, that will remove all of the images. So let's just do that. So I'm going to clean my cache. It tells me that it will clean everything from the cache. You can see what will be deleted, it says, by running the dry run option. So in fact, maybe let's do that to give you a demonstration. So I'm going to say I don't want to continue at this point, but instead I'm going to say -dry run. Right. So in this case, it's doing a dry run. So it's not actually deleting anything. It's just showing us what would be deleted. And the other thing that's really interesting here is we can now also see where these files are stored. So this is my home directory, and what's happened is that the Singularity command has created a .singularity directory in my home directory, and it's then created cache directories for all of the different types of images that you might be able to pull. And so Singularity cache clean on its own will delete all of those cache directories and everything within them. So any type of image that you've pulled using Singularity pull will get deleted. There is an option, or there are a number of options, in fact, to tell Singularity cache clean what type of images to remove. So as we saw in my output above here, I had some different types. I've got an S-Hub image that's pulled from Singularity Hub, and I've also got an image that's come from Docker, along with a number of these blob sections, which are the different parts of the Docker image. So I might only want to, for example, remove images that I've pulled from Docker. So a little exercise here for you to look at is thinking about what command you might use to remove only images of type S-Hub from your Singularity image cache. And I think I've probably already answered this part here. How could you test this safely to ensure that your command is going to do the right thing? So if you take a quick look at the help for that command, see if you can see what the options are. We'll give you just 2 minutes to look at that. And if anybody has any questions at this point, feel free to go ahead and ask. So I'm going to open this up now and just go through this, so you probably have time to look at the help for the command. So if we look at the command, the help for Singularity cache clean, we can see it's actually not terribly easy to read here because of the size of my terminal. If I maybe just drag that a bit bigger, it'll be a little easier to read. So here are the help options. So I've done run -- help, Singularity cache clean -- help. We can see the number of options here. We saw the dry run option in use just now. But the ones that you're particularly interested in here are going to be probably -t, so for image type. So if you were to say Singularity cache clean -t, and then you were to give it the type S-Hub, then it will remove only the images of type S-Hub. So we can see an example here, and it's very similar to that. So this is just demonstrating to you that there's some flexibility in how you clean your cache, and if you want to remove only images that you've got from Singularity Hub or from Docker Hub or whatever, there's some control over that. Okay, so I'll just drag that back again. So that's demonstrated here. So if you just run Singularity cache clean -type S-Hub, it will give you a warning. It will say, do you want to delete anything from, so let's do that and demonstrate that. So right, so that's telling you this will delete everything in your cache, containers from all sources, but in fact we've actually said specifically that we want to delete only the S-Hub images. If we do the dry run option, so I'm going to cancel that and say no, and if we do -n for dry run, what you can see there is that it would actually only have deleted the files. Sorry, I'll just drag this back again so you can see. It would only have deleted the files in the S-Hub directory. So that's how we can control that. And if you actually went ahead and run it, you'll get this message. You get the warning. If you say yes, you'll get a thing which shows you that it's removing, and it will actually delete those files out.
So Jeremy, there's a question asking if there's any way to control the cache size to make it bigger or smaller.
Right. So to the best of my knowledge, there is not at the moment. I'm not sure how exactly that works. I don't believe there is. I think your main way of controlling it is just by deleting things out that you don't want to be stored there. Of course, what you could do is you could create a separate file system, depending on what sort of system you're on or how things work. You could potentially create a different file system and mount that as your .singularity cache directory, and then you would obviously have control then over how big that file system is and how much space there is to store stuff in the cache. But yeah, I'm not sure. There may be a way to control it, but I'm in the Singularity configuration. But I don't think that's something that the end user would have control over specifically. But I can certainly check on that and come back if I have any further information on that. Okay. Right. So now we're going to come on to look at working with containers in a bit more detail. So we've seen how to pull containers, how to just run them basically with Singularity run, and we're now going to look at some other options for running containers. And again, you'll see some parallels here with the different things you can do with Docker. It's sort of similar kind of options here. So we saw that we could use the Singularity inspect command. So we used that and we saw that there was this little script that was running by default. But what if we don't want to run that script? So what if we want to run something different within our container? So we know that our container has got something else inside, some other software that's bundled in it. We want to run that. Maybe we want to just run a shell in our container. What are the options to do that? So as an example here, so in this case, we have our hello world container, and we're using a very simple command, bin echo, which just prints some text, echoes some text to the console, and we can assume that that is present in this container. Let's assume that we know that that is present in this container because it is. So if we want to run that, so at the moment my hello world image is not there, so I'm going to copy it back from the shared directory because I won't be able to pull it at the moment. So let's actually just get that from there. And right, so I've now got my hello world image here, and I'm going to run Singularity exec hello world bin echo hello world, and let's see what we get. So we get our warning again, which we don't need to worry about here. So I'm just going to drag it a bit wider so you can see. But there is our output. So what has happened here? The container, so we've got this image hello world.sif. We've generated a container from that image, and in that container that's been spawned, we've run the echo command hello world, and we then see the output. And that container has now exited straight away. And unlike with Docker, where when you run your container, you then get a kind of stopped container sitting in your container configuration. And if you recall with Docker, we used the --rm switch if you wanted to remove that container from the sort of stopped state when it's run. Here, this simply just runs, and then all of the state is removed. So the original image sits there in the directory. We run it, it's spawned the container, it's done something with the output, and then it's all disappeared. So that's just a sort of basic example of running something other than the default script that's in there. So the next thing now for you to have, hopefully you've been able to follow along with that. If you now look at this simple exercise, we're going to look at running something different. So based on that example, can you run something based on this hello world sif image that prints the current date and time? So see if you can run. So this is so there's going to be a command in that container that will print the current date and time. This is perhaps something that if you're familiar with Linux, you may know straight away. But see if you can find out some information about that, and we'll look at that in 2 minutes. Yeah. So there's actually a point in the chat there about pulling a Docker image instead, a sort of hello world Docker image. So that is an option if you can't pull from the Singularity Hub. As was highlighted, there is a sort of global limit on the number of pulls in the from Singularity Hub from a given host. So because we're all on ARCHER2, or I would think probably almost all of us are on ARCHER2, we're all pulling effectively from the same machine. So as a security, I guess as a security aspect, that there's some limit on the number of requests that can come from the same machine to the Singularity Hub, which is why some of us would be seeing the errors. I don't think there's anything else there that's not been covered. Yeah, so I noticed that there's a point in the chat about Singularity managing Docker images. We will come on to look at that in a moment, actually, in more detail. But yes, you can use Singularity to pull Docker images, and we'll look at how it works with them in a little more detail in a moment. Okay, so let's move on. Let's look at the solution here. So right, so for any of you that as I say that are familiar with Linux, there's a bin date command which will print the current time and date. So I can just run it locally on the ARCHER2 console. We can see that. So that's running the version of bin date which is actually stored locally in the ARCHER2 login node. But if I run my Singularity container, what I'm doing here, so I'm taking the image, the hello world image again, I'm telling it to run a container from this image, and I'm saying within that container that you create, run the bin date command that is inside the container. And there we go, we see, in fact, slightly different output, so that's a good example that the output is in slightly different order because we're running a different distribution of Linux within that container. So that's why we're seeing a different output. So in fact, something else we could do, if we want to have a look at what version of Linux that container is based on, we saw, I think yesterday, that you could look at the etc issue file. So what we could try and do is run our container and execute the command cat etc issue, and we should see what version of Linux, what Linux distribution is based within the Hello World container. So in fact, they see that that's actually an Ubuntu 14.04 container that's been used to build that image, and that's, I guess, is the format that's the default format in Ubuntu for the bin date command, whereas on ARCHER2 we see a slightly different format. So there we go. So yeah, so that's just an example of how to run different commands within the container. So the next thing you might want to do with your container is to run an interactive shell. So let's say that we want to open a shell in order to run something that we know exists within the container, or maybe we want to do some admin tasks within our container. Something that I should actually highlight, which I don't know if we discussed in the Docker material yesterday, but the image itself. So this image file that we see here, in the standard state, this image is effectively read-only. So when we run the image, when we run the image and create a container, anything that we add into that, the image itself, it remains unchanged. So when the thing shuts down, the image is back to its original state. It is possible to create writable images in Singularity. That's something that we can look at a bit later. I don't know if we actually cover that in the material, but we certainly look at building images, and we can look at making writable images during that. But in this current state, this is effectively a read-only image. The content in the image is read-only. What we will see in a moment is that there are still ways to save data within the image that we can then access when it shuts down. But we'll look at that in a moment. So we've shown that we can run different things from inside the container, but we want to with a container that's based on that image. We then want to create a shell that we can do stuff inside the container. So we have the Singularity shell command. So if we run Singularity shell hello world.sif, we now see, after the warning, a Singularity prompt. So we are now inside a shell in a container that's been created from the hello world.sif image. And again, we can see if we look at the etc issue file in here, we should see that we're in the Ubuntu 14.04 image. And what we can do is we can run some different commands. So let's say, who am I? I can see my username. If I run ls, I see that there's a hello world.sif image file. So that's kind of interesting. And we'll look at what we're seeing there in a minute. So we've opened this shell, we've run some stuff, and so there's a couple things for you to think about. What do you notice about the output of these above commands? So I've started this container based on this image. It's an image that's come from Singularity Hub. But when I'm inside it, when I run who am I see my own username. And when I run ls, I actually see there's some files in there. One of those is my hello world.sif file. So we might wonder where that's come from. So what do you notice about this? So this is just a quick thing to think about as a sort of brief exercise. And do you notice any way that this might differ from what you would see within a Docker container? So I'll just give you a minute to kind of think about that and to try and just to ensure that everybody's been able to catch up to that point. And then we'll have a quick think about what's happening there, and I'll explain in a little more detail what's going on. So I'll just give you 1 minute to look at that. So we're on this section here for anyone that's following along in the material. We had somebody who's posted in the chat there who's answered the question, what do you notice about the output of the above command? So the first thing that was highlighted is the user is not root. So that's correct. So if you went into a Docker container, you started a Docker container, you would generally find that the user is root. Here, the user, I'm my own user. So one thing that we might ask, so I'm going to actually just scroll this down so you can see, because we're going through this. So I downloaded this publicly accessible image, this hello world.sif image. The person who's created that image doesn't know anything about my username or what's in my home directory or anything like that. So how am I seeing when I go into that my username? So if you have any familiarity with Linux, then you may well know that in Linux, users, or Unix platforms in general, users and the user groups, so every user is assigned to a group in a Unix type platform, they're configured in these two files, etc. password and etc. group. So within those files, you get a list of all of the users and groups on the system. So it's clear that the configuration in this hello world.sif image will not have my user in it, because the person who created that doesn't know anything about me. They don't know I'm going to download it and run it, or they don't know who else is going to download it and run it. So individual usernames of people who are going to run it will not be in that file by default. So how is it that we are able to see that we are our own user in there? So what's actually happening here is that when Singularity runs a container from an image, it does a bit of kind of preparation work when it opens up the container, when it creates the container. So what it's doing is it's binding some directories or some file contents from the host system into the container that it creates. So what's happened here is that the container is created from our image, and inside the container there is a slash password and a slash etc. password and a slash etc. group file, which don't have any record of me existing in them. And what's happening is that Singularity on the host system is taking the details of my user and my group, and it's putting them into the file in the container before it opens up the container for us to access the shell. So basically it does some kind of preparatory work that ensures that our user configuration is in the container when the container opens. And that's what I've tried to illustrate here with this little diagram. So it's basically showing you that from the host system we have the etc. group and etc. password files, which are on the host, and because we have our accounts on the host which we've signed into, our details are there. And those details are then added to our particular user details, are then added to the relevant files in the container, so that the container knows that we exist and we can use our regular username inside the container. The other thing that's also happened here is that if I do a pwd, so print working directory, I can see that I'm in the same directory in my user home directory that I was in before I started the container, and that's because it's mounted my home directory into the container. So my home directory is basically visible inside the container. So anything that I do in this container now in terms of creating files or generating any output from something that I run, as long as I store it within my regular home directory, when I leave the container and shut down the container, although all of the kind of state of the container disappears, any files that I've saved in my home directory will still be visible there. So they will persist. So this is basically the same as what we saw in Docker when we did bind mounts with the -v option to mount directories into the Docker container. But here, this is done automatically for you for your home directory. And this is something which I believe is configured by the admins who set up Singularity, and they have quite a lot of control over what they mount into a container when it's created by default. So it's pretty common for, in most cases, I think you'll find that the home directories are available within a Singularity container. It's possible that other system-specific directories may also be mounted by default, but that will be down to the specifics of the platform that you're working on. But here, certainly, we can see that our user is available and our home directory is available, and that gives us a lot of flexibility because it basically means that we can create files that have the same ownership permissions and configurations that they do on the host system in the Singularity container, and when we then leave the container, those files are available to us and all the permissions are available as they should be. So that's quite powerful. It gives us quite a lot of scope for working with containers and being able to easily store files without having to manually mount lots of directories into the containers. I hope that makes sense. If anybody has any questions about that, then please do ask in the chat. So somebody's asked about whether it mounts /work too. So in the case of this particular container, we can see there isn't a /work. So basically, this is down to the configuration that the yes, in fact, somebody's actually printed the Singularity configuration. This is down to the configuration that's on the system. So not by default in this case, but potentially that's something that you know on a different configuration people could choose to do. Sorry.
Yeah, that's me, Jeremy. Just to note that if you had if you know we're all running on home here, but if you moved your container image to work and ran the container image from there, you would get the file, the directory you were running the container image in mounted by default as well. So you can mount /work by putting the container in /work and then running it from there.
Right. Yeah, and presumably you will also have your home directory mounted as well.
I haven't checked that, but I'm in a container, so I can just do that. Give me a second.
Okay, so it may be on this system that actually you just get the current directory mounted, or the current system.
So home's mounted by default, and you get your current working directory by default if it's not within the home path as well.
Excellent. Okay. Yeah, so that's great. So yeah, so if you were going to run something in /work, if you start your container in that location, then obviously it makes sense that you can access any files that are in that directory where you start it, but also you have access to your home directory as well. So yeah. Okay, so some questions and so a little section of questions and exercises here. So there's a question here about what do you notice about the ownership of files in a container that started from the hello world image. So you might have a look at the root directory of your container. So I'll just print that so you can see. There's also a couple of little exercises here to think about. So what happens if you try editing some files in this container? So you should see the /raw.sh. That was the file that was run by default, so we can see that there. You can probably see by looking at the permissions of the file what will happen if you try to edit it, but that's something to have a look at. And also in your home directory, you might want to try and create a file, just a simple text file or something there, and see whether you're able to successfully create that, and to prove that when you shut down your container that the file is still there. So I'll just give again a couple of minutes for people to just have a sort of look through those and have a think about the points that are raised there before we discuss those in a little bit more detail. Okay, so I've already used the ls-l command here, and you can see the files in the root directory of my container. So you'll notice that some of them are owned by root, and some of them are owned by me. Of course, because our user is us, we're not root by default in here, we won't be able to edit files in any directories that are owned by root or create files in any directories that are owned by root. And this is something specifically to note with Singularity. So with Docker container, you generally go into the container as you have root access, you can edit anything that's in the container. Here, the base configuration of the container in general will be kind of locked down and owned by root. So you're somewhat limited as to what you can do in the standard configuration inside the container. So while this has a lot of benefits, Singularity, in that you can run stuff in user space, one of the potential issues is that it's not always possible to change the configuration in this kind of approach of using the container. So for example, if you've got some software that's installed in the container and you decide you want to install something else, you're not going to be able to, in the standard configuration, if you just run the container like this, install something new into the kind of system directories within the container. You can, of course, put things into directories that are owned by you, so your home directory or whatever, but not into the kind of system directories. And one of the things that I'm noting here is we've got several directories that are owned by me, and I'm assuming that these are probably directories that are mounted by default from the host system. So certainly with home, we can see the home directory was mounted by default, but I imagine there's a few others that are being mounted by default as well, which is why they're owned by my user. So any of those directories are things which I have access to write into, in theory. So that's something else to note. The other thing, of course, that you may have noted if you tried to do this, if you tried to edit this file, you'll see, as we might expect, it's owned by root. We shouldn't be able to edit it. So if I try that, I should have put a slash in front of it. There we go. Right, so I can see the file, but I can also see at the bottom here that it's read-only. I won't be able to edit it. So if I try to type something in it, in fact, it's telling me I can't change a read-only file. If I try to save it, it tells me it's read-only and I can't. So I don't have access to change some of the files in the container that are, well, pretty many of the files in the container because they're owned by root. And so that potentially is something you have to think about when you're working with Singularity containers. However, as we pointed out, and it's probably, hopefully it's clear now, if you go into the home directory, so if I just do cd without anything else, that'll take me to my home directory. Here I should be able to create a file without any problem. So now I've created a file, I'm going to save it. There's my file. And if I now exit from that container and go up one level to that directory, and I look at my file that I just created, there it is. So I'm no longer in the container, but the file has persisted that I created within the container. So that's just as a result of the home directory being mounted into the container. So hopefully that's fairly clear what's going on there, and that gives you a little bit of an idea of the kind of general structure of how containers run and what's accessible in them and the permissions of the files and so on. So there were some questions in the chat a little bit earlier about using Docker images, or some discussion about using Docker images with Singularity. So that's what we're going to come on to look at now. So Docker images can also be used with Singularity, which opens up a huge number of different opportunities, because of course there's Docker Hub and there are other registries that are out there with vast numbers of containers on them. So Singularity now has the ability to work with those containers, which gives you a lot more scope in terms of things access and run. So Singularity itself doesn't actually run Docker images directly. What it does is it pulls them from the Docker Hub and it converts them into a format that's suitable for Singularity to run. So when you pull a Docker image, Singularity is pulling all of the various different slices from the Docker image, the bits that make up the sort of slices that make up the Docker image, and it converts them into a Singularity CIF image file. So what we'll end up with is something which looks very similar to our hello world.cif file, but it's actually been pulled from the Docker Hub. So moving on from the very simple hello world example, we're going to look at the official Docker Python images. So if we go and look at that, if I open a new tab there and I just switch across, let's move that across. So here is the Python image page on the Docker Hub. We can see that there are a large number of different versions of the Python images available. These are all the different tags that are available to pull things. So I've been using the Buster image. So Buster is a Debian release. It's one of the Linux distributions. And I was using Python 3.8.6. So I can see that that's a tag that's available to me. So if I go back to my documentation and information here, so this is what I've tried here. So if I now do Singularity pull, so I'm now going to tell Singularity that I want to pull something from the Docker Hub. So what am I going to save it as? So I'm saying Singularity pull. I want to save my image as Python 3.8.6. I think because we're doing the slim image, I should call it slim.cif. So that's the cif file that I want to have saved in my current directory when it's completed pulling it. Where am I going to pull it from? So if you recall, when we pulled the hello world image, we used the prefix shub like this to say that we're pulling from the Singularity Hub. Instead here we're going to use the Docker prefix, which will tell Singularity we're pulling from Docker Hub, and it knows internally where to go to pull the files from the Docker Hub, so the correct host name to use to pull from Docker Hub, so on. And the image that we're going to pull is Python, and it's Python with the tag 3.8.6 slim buster, and as we saw in the Docker Hub page for Python, this was the list of all the different tags that are available. So that's the one that we're pulling. We're pulling the slim image because it's much smaller. It's very cut down, but it will just be quicker to pull that. Now, in fact, what you might see, because I think when I showed you before my cache, we actually saw that I pulled this previously. So let's see what happens when we run that. So, in fact, that's actually run. And if I look here, oh, doesn't look, do we have it? Yes, we do. It's there. So what's actually happened there? We didn't see any output, and I think that's because the image was in my cache. And it's just basically saved it straight out of the cache. So what we could do here is we could demonstrate what we looked at before with cleaning the cache. I could clean that image from the cache, and then I can re-pull it, and you should see it pulling all of the different slices down. So if you recall from before, we had, getting confused between Docker and Singularity, there we go. So Singularity cache list, we saw that the image was already in the cache. It's an OCI image type. So what I'm going to do is I'm going to clear the OCI image types from my Singularity cache. So if you recall looking at the help before, we have this option to clean the cache. So we're going to go clean. We're going to say -t, and we're going to remove images of type OCI and blob. Do you want to continue? Yes. Right, so what it's now done is it's removed the OCI. I don't know if it removed the blob images as well. Let's just check that. Whoops, yes, I think it did. Forgetting to put the -v. Yes, it did. So now we can see that there's in fact only one container file in my cache. So the Python 3.8.6 image is not in my cache anymore. I'm going to remove the cif image from locally. So this is the one that I pulled from the cache before. And now we can try running that command that we ran before. So I just use my history to go back to the pull command that we ran before. So we're now saying again, we want to pull this Python image. We're going to save it as 3.8.6 slim.sif. We're pulling it from Docker Hub, but in this case, it's not in the cache anymore because we've just deleted it. So what we see now is a very different output. And we can see that what it's doing is it's going off now to Docker Hub. It couldn't just pull it straight from the cache and save it. It's gone off, and let me make this a little bit wider so you can see the output a little bit more clearly. There's a lot of output there, but the main bit we're interested in is up here. So you can see what happened. It said it's converting OCI blobs to SIF format. it's starting the container build, and what it's done is it's gone off and it's pulled from the Docker Hub the different slices that make up the sort of blob sections that make up the Docker image, and it's then converted those into a single SIF image file. And there's a bunch of warnings there that have come up to do with the file attributes. This is to do with I think it must be to do with the file system that we're working on, and this support for different features in the file system. It shouldn't be a major concern for us here. What the main thing we can see is we've created the file, it's saved it as Python 3.8.6 Slim. So if I now do an ls-l, I can see that the image is there. So that was actually quite a nice demonstration of how we can use the cache, and we delete something from the cache, and then we were able to pull again. You could see it actually pulling the file from the Docker Hub. So just switching back to the material here. So this is the output we saw, very similar to this. And in fact, this unpacking of the layers is actually there, but it's kind of a bit mixed in with the other output. So we can see here unpacking the various different layers and bundling them together into the CIF file. So what we end up with is the single file. So there's a question about logging into Docker Hub. So we didn't have to log into Docker Hub here because we're pulling public images. So if you were going to pull a private image, you would have to log in first. But here we're simply pulling a public image. So we've got an issue there with pulling one of the images. Right. So actually, I think that the issue there is that you've got in your command where you've got the fatal error, you've put the Python, you've put Python hyphen 3.8.6, and in fact the name of the image is Python. You need a colon after the image name. So you want Python colon and then the tag. So I think that's what the problem is with that error that's in the chat. So yeah, so if you change your command, your Singularity pull command, and put a colon instead of a hyphen after Python, that should solve the problem. Yep, great. Okay. Right. Okay. So I will move on. So now you've got this image. Hopefully, you've all been able to follow that and be able to pull the Python image from the Docker Hub, and we should now be able to run this as a regular Singularity image using the same approach that we used for the other Singularity images. So what I'll do now is just give you 5 minutes to have a go at running that. See what happens when you run the container just using the standard run command. What do you get? And see whether you can run some standard Python statements. And I'll just give you, probably don't need 5 minutes for that. We'll just give you till 11:35. And then we'll move on to the next section. And if you are having problems for any reason pulling that image, do post something in the chat. So let's just open that up. So this should be pretty straightforward. You should have been able to get the image to build. Hopefully for anybody that found it was taking a bit of time, that it's now completed, and you should then be able to run the image file like that. So we just simply run Singularity run, we give it the CIF file that's been created as a result of the pull. We run that, and there we are. We're straight away into a Python 3.8.6 shell. So that suggests that the run script that's in this image is set up to run Python shell fault. Before I do anything else, we could go and actually verify that. So using the command that we looked at before, if we do Singularity inspect -r. So in fact, you can see there's a reasonably complicated script there to run, but basically it's set up to run Python 3 as the command that it's going to run, and there's a bunch of other things in the script there, but that's the main thing to highlight. So it's basically going to run Python 3 and pass in any other parameters that are added. Let's clear the terminal there and go back to running that. So okay, so that's running the image. We can do any sort of standard Python commands there. We're in a standard Python shell, so you can see here. a very simple example. That's basically something that you can use useful if you just want to be able to test stuff out in the Python interactive shell and you haven't got a particular version of Python installed locally. The next part of this looks at running a shell. So again, that should be pretty straightforward based on what we've looked at before. So if you want to have a go now at running a shell within that Python container rather than running the Python shell directly, so just running an ordinary Linux shell, so probably bash, but you may find if you try to run bash that it's not there in the slim image. It may just have bin sh, but that's something to try. So have a go at just running the shell, an ordinary shell, and then once you're in that shell, you should be able to then run Python 3 and get into a Python shell, Python interactive shell from there. So I'll just give you 1 minute to try that. Okay, so you've been able to open a shell within your container, run the image and open it with a shell inside it. So we can see there the command is very similar to what we've looked at before. So we run Singularity shell, give it the image name, and we should see that we're straight into a shell. And what we can do then is we can echo $shell. We can see it is actually a bash shell, so I wasn't sure with that slim image whether it had a bash shell in there, but it does. And we can see again, if we just look at the issue file just as a quick guide, it's running Debian Linux 10, which is the Buster version. And so there we go. So there was then another question here, whether you could find another way to run a shell. So we did this just using the Singularity shell command, but there is another way that you could do that. So I think we looked earlier on at the Singularity exec command to run a particular, so we used that we showed running echo hello world or something as simple at the start. So the other option there is you could actually run Singularity exec with the image name and then tell it to run bin bash. Oops. And you get to the same place. So you're running a bash shell. Equally, if I exit from that, if you want to run just a simple sh shell, you can do that. If we echo $shell, do we find it might actually still be bash? I'm not sure. Yes, it is. So it's just linked to the same thing. So hopefully you've managed to get to that point. And that's just really kind of reinforcing the stuff that we looked at before with running the shell and running different commands within the shell. Okay, so that concludes this part of the second part of the material. What we've done here is we've looked at the caching of images, how it caches the downloaded images. We've also looked at using the exec and shell commands, providing different options for starting containers. And we've looked at how we can pull Docker images to start containers based on images from the Docker Hub. We've got about 15 minutes until the kind of official lunchtime. There's a couple of options. We could either stop here and start again at about probably 1:45. Maybe we just started sort of 15 minutes before the official time, just to have two hours break. Or we can move on to the next part of the material now. I think we might be better to break here. I don't know whether anybody has any preference on that.
Are there potentially Docker images that cannot be converted to Singularity images?
Are there Docker images that cannot be converted to Singularity images? That's a good question. I'm not actually sure. I don't think so.
You're bolder man than I. My answer was going to be yes, but I've not come across one yet.
Right, okay, that's possibly the best answer, I would imagine. I think that's possibly is the best answer. Yeah. So
I think,
yeah, so there's actually
I think Will's point's a good one actually, in that there's likely images that would be able to be converted but then not be usable in the way you'd want to use them.
Yeah. So yes, I think that's probably true. Okay, so that concludes the kind of morning session of this. This afternoon we're going to move into a section where we're going to look at actually building Singularity images, and we're going to look then at how to run on an HPC platform, and hopefully we'll be able to actually run some MPI parallel code on ARCHER2 or whatever platform you may be running on.
What would be the hold up for using containers you'd convert from Docker, and why wouldn't they be usable? The fundamental difference between Docker and Singularity containers are actually usually Docker and any container solution you run on a multi-user system, such as an HPC system or otherwise, maybe things like Podman or Charlie Cloud or things like that. The fundamental difference is when you're on that shared system, you only have access to be able to do things that you would normally be able to do as a user on that system. So anything that you normally wouldn't be able to do on the system because you don't have privileged access, you still won't be able to do in the container. Okay, because that's the whole point of those containers on shared systems, is they restrict you to what you can normally do as a user. So you constantly see other people's files, you constantly access network configuration that you weren't allowed to access before because you're in a container. And that's the reason why these things exist, right? So you can't escalate privileges by just running in a container, because Docker containers give you access to everything as if you're root, essentially. Now, when you go and run Docker containers in a place that you don't have quite the same sort of level of root access, say on the public cloud, AWS or something like that, then you may still be restricted on what you can do with Docker containers, but it's up to the cloud platform to make those restrictions happen, not up to you within the Docker container.
Yeah, that's a really good point. Thank you, Andy, for highlighting that. Yeah, absolutely. So yes, this is very, very much the case that it's kind of a trade-off, I suppose, in the sense that you lose some flexibility in terms of being able to do kind of administrative tasks in the container as you could with Docker, but equally in doing that, it means that there is actually the opportunity to run these containers on other types of platforms where Docker wouldn't normally be made available. So yeah, it's I guess a bit of a trade-off, but it's certainly an important point. Okay, thank you all very much.